have engineered cow's muscle cells that can multiply without the assistance of an expensive and energy-intensive growth-boosting substance. If scaled up, they are optimistic this could slash the production cost of lab-grown meat, but they stress that it is still early days. Lab-grown or cultivated meat can be produced from animal cells approved for sale in countries such as the US and the Netherlands. It has been touted as a more ethical and sustainable substitute to conventional meat by avoiding the slaughter of animals and using fewer resources such as water. But the current small-scale methods of producing lab-grown meat have still proven to be extremely energy intensive and expensive. To grow cells outside an animal, they must be cultivated in a cell culture medium, a mixture of nutrients and growth factors. The latter latch onto receptors on the surface of animal cells and tell them to grow and differentiate, making them a crucial part of the mixture, says Andrew Stout at Tufts University in Massachusetts. Currently, this makes up around 90% of the cost of lab-grown meat production, so Stout and his colleagues wanted to come up with an alternative approach. They first built small DNA molecules called plasmids that contain genes with instruction for cells to produce their own growth factors for fibroblasts, cells that help to form connective tissues. The researchers then asserted these plasmids into cows' muscle cells, finding that they differentiated into skeletal muscle cells, common components of steaks and beef burgers that grew and multiplied. Although the researchers only experiment with cow cells, they think the techniques will also work on cells from other animals, such as chickens and pigs. They hope these engineered cells could one day aid in expanding the scale and lowering the cost of cultivating lab-grown meat. Give a cell a fibroblast growth factor and it will grow for a day. But you must teach a cell to produce its own fibroblast growth. That is called the fibroblast growth factor and it will grow forever, says Stout. This is just a proof of concept, but it is really exciting to think about how cells can be our allies in this endeavor and we can engineer them to help us. According to Eleni Theodoso at Aston University in Birmingham, UK, there is still a long way to go until lab-grown meat becomes a commodity, but every day we are getting a step closer to it. Issues that need to be overcome include the team's cultivated meat growing slower than with conventional approaches, says Theodosu. In addition, foods that contain genetically modified organisms, such as this plasmid, are only legal in some countries and there is still a widespread reluctance to eat them, she says. Beyond the report.